What's up, biotech kids? It's your favorite teacher, Coach Hyde. This is what we're working on today. Going over your molar mass quiz. Okay. So a couple things before we get started. So one mistake I'm seeing is that y'all are just typing away at this calculator, just hitting in them numbers, and I don't know if you know, but this thing is smart. All right. It's going to do, please excuse my dear Aunt Sally, it's going to do things in the order of operations. So just because you put it in there the way you want it to do it does not mean that's the way this is going to do it. So be careful. If you don't know your order of operations, do it step by step. I know my order of operations, but I still do it step by step. It just kind of goes quicker. So what I mean by that is just do one thing at a time. So like 2 times 3, enter. Plus 3 times 2, enter. Plus 5 times 8, enter. So you just kind of keep hitting enter, just go step by step, and then you control the pace, and you ain't got to worry about the order of operations. So be careful with that. Next thing up, so I'm going to break down each one as quick as I can. Yes, my handwriting is bad, but you'll be okay, all right? So the way I do it might not be the fastest way, but it will kind of help separate things, help you break it down, each one, and maybe make a little more sense of it. So that being said, let's get started. All right, up first is salt. This is sodium chloride. So that is NaCl. Okay, this is not Ci. That is not carbon and iodine. That is chlorine. If you're not sure at this point until you get used to using that periodic table, ask. Ask, is it Cl or is it Ci? All right, so we got NaCl. There is not any subscripts here, so this means that there is one of each. It's just like in math. If there's an X, we can understand this to be 1X, right? So there's one Na. I'm just going to round things just to kind of keep it quick. Na is 22.99, but just to kind of keep the math easy. For now, I'm going to do 23. All right, so we got 23 and 35, right? Yeah. So there's just one of each. I just add these two things together. 23 plus 35, right? This is going to be what? 58. I'm not done there. I need my unit for molar mass. Grams per mole. There's 58 grams in 1 mole of NaCl. That's what that number tells us. That's what that unit tells us. All right, up next is water, H2O. So H2O. We got a capital H, capital O. So these are two things. Okay. I have 2 hydrogens, right? So the mass of hydrogen is 1. I have 2 of them. 1 times 2 is 2. Okay. I have 1 oxygen, 16, right? So there's just one of them. So 2 plus 16 is 18 grams per mole. There's 18 grams in 1 mole of H2O, 1 mole of water. Up next, hydrochloric acid. Again, this is not Ci, this is Cl. HCl. There's 1 of each, so 1 times 1, and then 35. This is, we add them together, 36 grams per mole. Right? Stuff up in another color here. All right. Up next is aspirin. All right. Aspirin is C9H8O4. Right. So if I kind of separate this out into 3 little stages here. So carbon, there are 9 carbons. Right. The mass of carbon is 12. 12 times 9. No idea. 108. Right? There are 8 hydrogens. The mass of hydrogen is 1. 1 times 8 is 8. Right? There are 4 oxygens. The mass of oxygen, 16. 16 times 4 is 64. Okay? Then I'm going to add these together. All right, if I add all those up, 108 plus 8 plus 64 is 180 grams per mole. So for aspirin, there's 180 grams in 1 mole. That's what that means. No, that's worse. Up next, hydrogen peroxide. Very similar to water, but not at all. H2O2. There are 2 of each, right? The mass of hydrogen is 1, so you multiply it by 2. The mass of oxygen is 16 times 2, right? 1 times 2 is 2. 16 times 2 is 32. 2 plus 32 is 34 grams per mole. There's 34 grams in 1 mole. Moving on. Baking soda, NaHCO3. Okay, we got a couple of things here. So that's one, that's one, that's one, right? So we're looking at that capital letter to lowercase. So every capital letter marks a new element. Capital C, capital O is very different than capital C, little o. This is cobalt, this is carbon and oxygen. Okay, so look for those capitals. So sodium, there's 1 of them, it's 23. 1 hydrogen is 1, 1 carbon, 12, 3 oxygens, so 16 times 3, what's that? 48. So we're going to kind of add these together, right? 48 plus 12, enter. Plus 1, enter. Plus 23, enter. Right? 84 grams per mole. Alright, up next is sodium sulfate. What happened? Why did we get all blurry? Oh, did it just get weird? I don't know. We'll see. Sodium sulfate is Na2SO4. All right. So let's kind of unpack this one. We got Na2S, so capital, right? Kind of give myself some more room. So we're going to do the mass of Na is 23. We're going to do 23 times 2 is 46. Sulfur, there's 1, 32. There's 16s are oxygen, there's 4 of them. 16 times 4 is 64. So we add these together. $142. If you're not rounding these, if you're just using the number, right? If you're using 15.99 for oxygen, you don't do anything different. All right, it's all the same. It's just harder for me to do in my head. That's all. Right. Up next, barium nitrate. So we got BaNO3(2). Now, one quick way you can do this, the way I would kind of do it in my head, the way you could probably do it once you get used to it, is use your distributive property of mass, distribute this 2 in through there. All right, but right now, what you can do, if these are the ones confusing you, right, so this 2 means there are 2 of these. So you can erase this 2 and make you 2 of them, help you visualize it more. So that's, now I ain't got to worry about distributing in no 2s, ain't got to do no crazy algebra work, right? We can just count them up like we have been doing. So BaN, right, just like we've been doing. Ba is 137. There's just 1 of them. There is 1 nitrogen, 14. There are 3 oxygens, right, 32. What's that, 48? There's 1 nitrogen, there's 3 oxygens. And then we just add them together. So what is that? 137 plus 14 plus 48 plus 14 plus 48. 261. Right? So we just kind of took that 2 and separated it, right? This 2, we took that 2, right on the little squiggly line, right? Took that 2 and made us 2 of them. So we'd have to distribute. The other way, I would remember that you could do this. Is also, you don't have to deal with the distributing. Is, all right, well, barium is 137. And then you kind of look at this in the parentheses, all right? So that's 4 plus 16 times 3, right? No, I can't do that right. 4 plus, so that's 62. All right, so you know there's 2 of them. So you can do 2 times 62, which is 124, and then just add those together, right? You should still get the same answer. All right, moving on. Iron 2 hydroxide, FeOH2. All right, so remember what we're going to do right now, and you don't have to do this if you're getting good at it. We're just going to take that 2 away and say, okay, there are 2 of these. Right? So now we're going to work through it. We got 1 iron, 1 oxygen, 1 H, 1 oxygen, 1 H. Iron is 56, 16, 1, 16, 1. Right? We just add them all together and get, I believe, 92 grams per mole. It's just easier. It's just easier if you separate it for now, not have to worry about what that 2 does. All right. Aluminum sulfate, Al2, right? SO4, 3. So same thing, right? We're going. This 3 means there's 3 of these. All right, so we're just going to get rid of that. SO4. SO4. Right? So there are 2 aluminums. That's 2 times 27, 54. So 54. Okay. There's 1 sulfur, 32. There are 4 oxygens, 4 times 16. Right? And that's going to be the same for all 3 of these, right? So if I can just kind of simplify this a little bit, I'll do 32 plus 4 times 16. 4 times 16 plus 32. So this is 96. So this 1 sulfur and 4 oxygens in here is 96. I also have 1 sulfur and 4 oxygens in here. 1 sulfur and 4 oxygens in here. 96. I just add them all up, right? 96 times 3 plus 54. 342 grams per mole. Don't forget to use your unit. Don't just throw stuff in the calculator without knowing the correct order of operations. Take your time, especially when you're dealing with them subscripts, to know what it does, right? If you're not good at distributing it through, break it down this way, at least until you get comfortable, and then you can start kind of skipping some steps, like as you get better. All right, good luck.